Good afternoon. So this afternoon, I would like to start off with just pointing out to a few resources we have. So the web is a good starting point to find a lot of NDSU sources. So the easiest always is to just Google, and one of the things that I would recommend you maybe want to look at is the dry bean production guide, which has a lot of the details of some of the talks we're going to give. We're going to give more or less a update today, but you can Google the dry bean production guide, and it is a small booklet. It's also a publication available in hardback. So in it, for instance, it has growth stages. It talks about some of the weed control, fertilizer, insects, etc. So I would highly recommend that you use this resource if you can. So as we are going to talk about the dry bean, we're talking about a plant that can fix its own nitrogen if it has the right bacteria available. However, if you compare it with soybean, the plant is a lot less nodulation ability than with the soybean. And oftentimes, you also find that number of growers are just saying, well, forget about the nodulation, but just apply some of the nitrogen. So, but I still am a firm believer that if a plant can fix its nitrogen, we should probably try to do the best so that we actually have nodulation. On the left of this picture, you see a root with a lot of nodulation. So in most of the breeding programs, the breeders are now looking towards a more the standability of some of the varieties. So basically, we're looking at a type 2 intermediate bush so that we can have beans in the plant, harvest directly. And in the several classes that we are growing, the whites and the black beans are a little bit easier to direct combine because of the stature compared to the pintos. But there is a lot more effort in breeding the pintos to be more standing up. So just giving you a little bit of background of where we are in the dry edible acres. This was data from last year in the blue bar on the right. So you can see we were a little lower in acres compared to the two previous years. But for North Dakota, our main is the pinto with about 73% of the acres with black, and then navy, and then there is a few acres with others. But the pinto is our major production. So I'm just going to kind of go over some of the classes here quickly. And what I've done is I used the statistical service data. So on the bottom, you'll see the year from 90 to the last kind of the prediction of what we have harvested in 22. So I used the state average bean yield for that. And then all the dots are indicating the statistical reported yields, farm yields for black beans in North Dakota. So if you look at all those dots, you can see they move around quite a bit, and that is all dependent upon the environment, the year. I'm going to point in the pinto beans out a couple of years with dry and wet conditions. But if you look at that trend line, that would kind of indicate that there's about a 10 pound increase on a yearly basis. So that's kind of what we anticipate. And that yield gain is due to better genetics, but also due to all the work that you are doing with better management. So that's a combination. And over the years, we have seen an increase. So that's basically what we can expect. So on a yearly basis, about a 10 pound per acre increase. Now this is for the navy bean, kind of the same setup here, the pounds per acre on the left, and then all the dots represent the yields during those years. And again, you can see there is a trend line. If you look at that formula, that is where I get that 20 pounds per acre increase. So the navies have increased a little bit more rapidly than the black beans. And then what I want to point out is that there is quite a bit of relationship between the environment and with what we expect for yield. So here is based on what the survey among growers is indicating for excess moisture conditions in the percent of the fields. So in 2018 and 2020 and 2022, we have relatively low rainfall during the season. We had some issues with planting time, but not during the season. So those are the drier years. So, and then in 19, we had a wet year. So if you look at this particular graph, now we're talking about the pinto bean, and I'm indicating the drought year. Of course, when you have no water at all, which was last year, the yields are very low. But if you have a wet year, it tends to be under the trend line. And if you have a dry year, but we have enough moisture, it is above the trend line. So we definitely know that with drier conditions during some of the growing season, but there is enough moisture, we actually are doing better with our yields. So for the pinto beans, they have been increasing at a rate of about 20 pounds per acre on a yearly basis. So I'm going to now talk a little bit about some of the variety booklets. I handed out some of the booklets here. We have a few more about the variety trials that are conducted in North Dakota. So I'm just going to walk you through where you can find some of the information. So I handed out the hard copy. You can also find it on the net, on the web. Easiest is, again, to Google NDSU variety trials, click on the dry bean, and then there is a publication section on the right. You click that one and you will get this brochure in a PDF format. So besides having a publication in the printed form and a PDF, we also have a little tool that can help to kind of evaluate between different varieties. That one is a little bit newer, and we can find it the easiest by going to vt.ag.ndsu.edu. And what it does, it is giving a beginning of the site with wheat, where you can, or sorry, with beans, where you can select the location, what you're most interested in. And then if you click, for instance, on the Langdon data, then you can either put it into a graph, or you can get the data as far as numbers. So this will is easy to kind of compare. You can click on a few. So what I did here is I was interested in some of the blacks. So I took 4 of the blacks and then looked at the various yields. So if you like visual, easy, you can use this tool. So now I'm going to kind of look at a few tables that we have in the booklet. And I first want to mention that in some of the early tables in the booklet, the yields are expressed in a percent of that yield level in that particular location. So because the yield level, like say in Langdon, might have been 2,000 pounds, but if you go to the west, it might have been 1,200 pounds. It is hard to kind of put them all in one table. So if you take the mean of the trial and you express the yield of the varieties as a percent of that, that gives you then, if it is above 100% in each location, you kind of know that that particular variety is doing well. And I'm looking for stability. So the first tables in this booklet will teach you something about the stability. But here I'm looking at a pinto bean trial. The data is directly from the book, but I want to point out a few things here. So the varieties on the left, and then I have the direct harvests, and then the protein and seed weight and yield. So this one is irrigated. We also have data here for drylands, but I'm just going to give you an example. Now, the direct harvest number is a relative score to kind of estimate. The agronomist looks at the plot and estimates the percent of the beans that actually will make it into the combine. So it is kind of an indication of how well that particular variety is standing up in the harvestability. So if you look at that data over time, so this is the harvestability in percent, and now you're looking at the 2019 all the way to 2022, and then the last column is the average. And if you start looking at the averages, you can see that Lariat had on average 64% of the harvested, was expected to be harvested if you was doing a direct combining, versus some of the other ones where the highest was like 87%. So this gives you an indication of the harvestability. Now, this is direct harvest. If you would just put it in the SWOT, the numbers, of course, would be different. So this is only for direct harvesting. So the next thing I would like to kind of talk about is the column about maturity. This is days after planting. So as you can see in the column, there are different numbers, and I'm just looking at the relationship between the plant in the field and the yield. So as an example, Andy Falcon on the left and Palomino on the right, you can see one is still green and one is more mature. So you kind of think that the longer plants in the field, the higher yield potential there might be. So what I did here is on the bottom is the days after planting. So it goes all the way the scale from 88 to 100. And on the left, you can see the pounds per acre. And so for each in this trial, in the irrigated Carrington, I put a dot there. And you can see, yes, there seemed to be a relationship that if the plant was longer in the field, you probably get a little bit of higher yield. So the same trend would apply for crops like soybeans, where we know that a longer maturing variety has a yield advantage. But if you look at the dots, you can see that there is variability. So there is somewhat of a relationship, but there are you still need to kind of select the variety. So for instance, the tallest blue dot here was slightly earlier than two of them later maturing. So there is still the reason to look at the actually yields, but it helps you to kind of look at the relationship. So I'm just going to summarize some of the data here based on some of the environments. So we have here pinto beans over 7 environments in 2022. And I kind of ordered them here from low to high yielding, and that is the 7 environments in North Dakota, all the way from the west in Minot, and then also including some of the irrigated, and then also Langdon. So you can see there is here a difference. Mind you, the scale starts with 1,500 pounds. Now, I always like to see trends over locations. So which one is over locations doing well, but also over time. So if you look over time, then you go and add some of the environments. Now, within this class of pintos, we have also some what's called the slow darkening. And the slow darkening is introduced a couple of years ago. And what it does is it keeps that pinto bean more white looking for a longer period of time. And that is for marketing purposes important. So when we now look at the 2 white bars here, those are those slow darkening types. But now I'm looking here at 2019 to 22, total of 32 environments. And the letters above the bars represent the statistical difference. So if one letter is similar, we cannot distinguish if there's any significant difference. So the bars, the 4 bars on the right, all have an A in them. So statistically, they're not different, but they are different from the ones on the left. So there is a difference between varieties, and especially when you look over time, you can get a better idea. So that was the pinto bean. Now I want to kind of do the same story on the black bean. This is a picture taken from Carrington, and we see here blacktails, Eclipse, Zorro, and the Twilight. So when we look at 2022, now we look here at the bars AAA, blacktails, Eclipse, and the Twilight were significant, or not significantly different, but were all higher than the Zorro. And then when we look over time, we combine it now over 19 sites. I don't have all of them, but the blacktails, and the Twilight and the Eclipse were not significantly different. So you can see they're very close. So basically what it says that those over time have been kind of equal to one another. So the last one that I would like to show here is the navy bean. Again, done in 2022, 6 environments. And ND Polar is a newer one, and you can see that one is the highest yielding in 2022 over the 6 environments. And if you look at the mean separation, the ND Polar is significantly higher than the Medalist, the Armada, and the Blizzard. But I did not have the data for the new one for the many years because it is a fairly new one. So I just concentrated on the 3 that were consistent across. And again, across the 24 environments, there was no difference between those 3 navy bean varieties. However, we hope that the ND Polar keeps the trend and that in the future, when I combine data over more years, we can better see if there is a mean separation between the different environments. So just to kind of summarize some of the things that I want to kind of think about in variety selection is that, of course, the variety testing that we do, we try to plant in an optimum time frame. The results are going to be different if you are late in planting. We also have to think about the yield potential in relationship to crop rotation. If you do no-till versus till, and of course, results will differ. If you have a salinity issue, yields will be definitely lower. Fertility level and an excess moisture, as I showed you in the graph, will reduce yields, so that will have an effect on how your variety will do under those conditions. And then, of course, last year we had a drought condition that also affects yield level. So those are some of the factors that play into that selection of varieties that, you know, we always want to have the best conditions. We have not all the conditions under control. So with that, I will finish my presentation and we can move on to some more agronomy here.
Good afternoon. Thanks for joining our session. And I'll continue with some agronomy discussion on dry bean, in particular on plant establishment. Before I do that, I'll actually I wanted to give Hans an opportunity. He talked about varieties. Hans and I and many other people on the variety release committee, and we met yesterday. And Hans, you won't get fired if we talk a little bit about the no, but you can talk about varieties. Okay, I'll do it. I'm closer to retirement than you are, so if I get fired early, no problem. Anyway, the bottom line is that Juan Sarno presented a slow darkening pinto yesterday, and it was approved. Now, it's not official yet because our experiment station director needs to approve it, but it's very likely. So this variety is very good yielding. It's certainly better than Palomino, and it's actually in the database that Juan had presented, it's yielding better than Vibrant, the #1 slow darkening pinto that's been growing in the state. Plus, it has larger seed size. So I'm sure Hans will talk about a bean day if you guys plan to attend that in a couple of weeks. So anyway, a little teaser about something we're pretty excited about. Is that okay, Hans?
Perfect.
Okay. So I'm going to advertise just a little bit. Hans and I have been involved with Getting It Right webinars over the last several years, and we just completed one on soybean and on dry bean in December. If you happen to miss that, you can view the videos. Frayne Olson was one of the speakers, and there are a number of other people. So if you're interested, all you need to do is get on the web and just type in NDSU Getting It Right, and you should be able to find this page where you can view the videos if you wish. And then we do have 3 more Getting It Right programs coming up. One in corn later this month, and then we have a canola and sunflower in March. All right, dry bean presentations. I kind of like this. I do like to start with this listing, and I may be boring information to those of you that have a lot of experience with dry beans, but at least want to get everyone on the same page. And in particular, it may be useful for people that are considering growing beans, or those that have not a whole lot of experience. So I'll just mention a few basic things, and then from there I'll get into the main content of my presentation. Keep an eye on the time. All right, so some pros, and I've consulted with quite a number of people. This list continues to change a bit, And if you have any suggestions to me to improve this list of either the pros or cons, please let me know. So the pros on dry bean, adapt to the most regions, but certainly we need soils that are well drained and soils that have very low salt. Most definitely. Profit potential, that's maybe why you guys are here. Out of Carrington, we have a farm business management person, and very consistently, when he looks at all the crops that he deals with, dry beans are year in and year out seem to be near the top or at the top on profitability. Crop rotation, people are growing soybean or maybe in the West some pulses. Dry bean may be a real nice substitute for those if you're struggling with those. On production, timing of planting and harvest seems to fit well with more of our traditional crops. Fertilizer, Hans talked a little bit about inoculation. Based on our annual grower survey, typically it's around 85% of people that complete the survey that say that they do not inoculate. And we're wondering, maybe we need more education on that. But granted, soybean distar, they are not as responsive to the rhizobia bacteria as most of our other legumes. It requires low N levels, of course, and P and K are important, as well as zinc. But anyway, it's pretty simple on plant nutrition for dry bean. And then finally, direct harvest is growing based on the survey that we have, and we just know that there's more and more bean acreage that is direct harvested. And a lot of that can be attributed to genetics and probably some to equipment as well. And of course, there is a con column, so I want to go through that. And a lot of these would be compared to soybean, with a few exceptions. With conventional till, yeah, we're really concerned about soil erosion. I think everyone would agree with that. Increased direct costs compared to soybean. Remember last year in the crop budgets? By the way, Frank, are the budgets out yet? So if I remember correctly, last year, the indirect increased direct costs were in the neighborhood of $80 versus soybean, and for this region, for North Dakota. But on profit potential, if I remember correctly again, I think that it was like $70 an acre more on profit potential with dry bean versus with soybean. We'll see what Brian and his co-workers come up with this year on the crop budgets. I'm sure it'll be better, won't it, Frank?
Of course.
All right, plant establishment, yeah, this is a little more difficult with dry bean as compared to soybean. Full season weed control, we have less herbicides, we have more resistant weeds. The canopies typically don't fill in like soybean, so it's more challenges. I think anyone has experience with growing beans would agree with me. Disease, yeah, that's certainly a challenge. And I'm not sure why we don't have Sam Markel with us this afternoon, but we'll have to fix that next year, for next year's program. Numerous sprayer passes, harvest, there's a lot of things to be considered. And marketing is not like marketing wheat. Okay. Again, if you have any suggestions on making this better, this list, talk to me and I'll make the revisions. So some of the things I'd like to talk about, my list is short because I'm down to 15 minutes. So I want to talk about our decade of work that we've done with plant populations and row spacings. I actually talked about this last year and at some other meetings, including or besides the Lake Region Roundup, and I get some input from people. I know it's constructive criticism, but anyway, I got to give you a little background information on this, and then we'll get into the data. I also like to talk a little bit about minimum stands, and then using rye as a preceding cover crop. So that's my plan. Maybe there'll be a few minutes left to talk about other subjects before we get into the economics or market update. So here we go. So as you know, for many years, NDSU has recommended 70,000 plants established in pintos and 90,000 on black and navies. And that was based on prior research that was done by people, Ken Grafton even. I know some of you remember Ken Grafton, some of you guys with more experience, Dwayne Berglund. And that was based on wide rows. And certainly the trend is narrow rows. So we thought we need to do some of this work and just see with the trend of narrow rows and more productive genetics, we maybe need higher plant population. So that was a basic reason for doing the work. So these are agronomic studies, and our equipment is not always the newest at research extension centers. And so sometimes we have odd row spacings. For example, we have 14-inch rows that sometimes we'll use. And people said, well, I got 15-inch. So this really doesn't apply. Well, I think that's 14 is pretty close to 15. And I think we can say that they both should perform quite similarly. So I define the row spacing as either narrow with that range, intermediate with the range of 18 to 22, because we will use 18-inch, we will use 21-inch, but we also have used 22. And then wide rows, yeah, nobody has a 28-inch planter, but we do. And to keep things consistent, we need the same planter or same planting equipment for all the row spacings. Otherwise, we change equipment based on differences in row spacing. Well, that confounds the study. And it's hard enough getting statistical differences in our means without really goofing things up with having different equipment in one trial. Okay, and then white mold essentially absent. And I know you guys are concerned about that, rightly so. And Michael Bunch, our plant pathologist at Carrington, has done a lot of work, as was talked about this morning during the soybean session, but it was alluded to dry beans as well. Michael did do work with row spacing, extensive work, row spacing and plant populations. And you can go to our website and look at it. A warning, there's going to be a lot of details. Yeah, so you're going to have to study it closely, but there's some good stories there. Or you can use the QR code here and see some of the data if you want to do that right now. All right, and then economics, we're assuming that existing equipment is available to go from wide to narrow rows. If you have to buy new equipment, then you just need to keep that in mind based on what I'll show you in summary on our results with the rows, times, the plant populations. Remember last year, there was a gentleman here during the roundup when I talked about this. He asked, well, I only have wide equipment, and if I change, this is going to be expensive. Maybe I should just go across the field twice and get my narrow rows. And maybe that would work, but not for everybody, I assume. All right, so with that preliminary information, I want to go through the 3 major market types to show you a summary of our results. And then we do have a publication. If you want more details, you can look that information up. So we'll start with black beans. When we looked at the 2-factor interaction, there was not a significant differences in yields. We got to split the factors. So here's row spacing. Note there's 4 site years of data. It was all at Carrington, and we did see, oh, here's this funny number, 14-inch. But anyway, our narrow rows performed better compared to intermediate or wide rows. And then if we look at plant population down below, this was 8 site years of work, including in this area, Park River, as well as in Prosper and Carrington. Notice down below the established plants from these planting rates, about 100,000, about just under 120 and about 140. And there's no difference in yield. So that's quite interesting that there wasn't a response as compared to the other 2 market types where we did see a response. So in the black, or excuse me, on the navies, this was 3 site years of work, all at Carrington. And we certainly saw a response to row spacing, just like we did with the blacks. And less so though with changes in plant population. But ultimately, our highest yields were with the narrow rows and with plant populations, not seeding rates, plant populations starting at 65,000 and then going upward. And then with Pinto, this is 4 site years of data, work at Carrington, as well as Brian Hansen at Langdon cooperated with me on this. And note that we did see our biggest impact was with row spacing, going from wide to intermediate rows. These are 2 row spacings that we worked with. And yeah, and then we saw our, excuse me, I gotta go back one. I'm thinking ahead here. So on the navy beans, yes, when we had plant populations greater than 115,000, quite a jump from our old standard, that's where we saw the highest yield. 115,000, greater than that, plus the narrow rows gave us our highest yield in this trial. Now with the pintos, yes, row spacing helped us going narrower, and there was less impact going with higher plant populations when we when we considered both of the factors. So at 65,000 higher with narrow rows or intermediate row spacing, that's when we saw the highest yield, as compared to wide rows and the traditional row spacing. Yeah. But how about if we split it out? Here, this is a comparison of plant populations and going down to 70 first off, and we did see a decline in yield. Then how about going the other way? This is 3 site years of data from Carrington and Langdon, and notice that we did have about a 5% yield increase going from 72,000 up to over 85,000 plants. So this is a summary. Again, it's comparing our old standards with wide rows and 70 or 90,000 based on the market type. With blacks, we did see improvement in yield with the narrow rows. With the navies, narrow rows and greater than 115,000 plants. And with the pintos, intermediate row spacing and plant populations somewhere above 80,000 appears to be the sweet spot to increase yield.
Yeah.
That is established. Yeah, you guys got to figure out planting rate. So here's the details. If you want the information on the web search, if you just search NDSU bean rolls and pop, that should be one of the first publications that come up. Black and bean, and then that one was revised just last spring, and then the pinto bean we just got published in May of last year. All right, so you probably don't have this problem, but maybe your neighbor does, and you might want to help them out. Occasionally, people do have low plant populations, and but I knew we in our trials through the years, every once in a while we do have disappointing populations, and I thought it'd be good to graph that and just see what happens, what kind of yields we got. So this is from one of our extension publications, just showing for many crops the minimum stands, including with navy and black as well as pinto. And so I don't know, is this liberal or not? It may be, but we're also assuming that the plant density is fairly uniform. And I think that's a poor assumption, because usually when we have poor stands, we'll have decent stands here, and then over here they're pathetic. And anyway, and then along with that, when we have these lower stands, it really increases management. It's so much harder to manage weeds, and plant development is